Hey, good afternoon. My name is Mark Feit. I'm a principal software engineer at Internet2, and I'm a member of the perfSONAR development team. And this afternoon, we're going to discuss the pScheduler API. We're going to start out with some of the basics. We'll talk about why we have an API in the first place, and which is actually very simple. It was kind of a design decision on our part. We did it to put all the business end of pScheduler in one place. And there's sort of a line in the sand that we drew that said anything that uses pScheduler stays on one side and pScheduler itself stays on the other. This gives us a whole bunch of additional options. The development team can rewrite the entire thing on either side of the line, and as long as we don't change the API, no one's going to notice. Everything that uses pScheduler, as I mentioned a second ago, uses the API. So the command line interface, mesh config, which is actually treated as a third-party application, and anything that anyone else writes will all operate through the API. So nothing sees the system's internals. One of the things that this gets you is that it lets you turn pScheduler into a building block for other systems, which I think is probably why most of the people who are here today are here, because there has been some interest recently in doing just that. There are a few things that I'm going to assume you understand. One is just sort of the basic concepts of perfSONAR, what it is, what it does. And I will also expect that you've at least played around a little bit with pScheduler, you understand some of its concepts, and maybe have used its command line interface a little bit. Additionally, the technology stack that we use for this API is three parts: HTTP, which I'm sure most folks are familiar with, JavaScript object notation, JSON, and representational state transfer, which is REST. Those are the three pieces that make up everything that you need to use the API. Additionally, we're going to cover some examples. You'll see a few things using the curl command line utility, and we're also going to dissect a sample program, which is written in Python. Understanding of both of those is optional but helpful, and most of what I'm going to show you today should be fairly self-explanatory. So even if you're not familiar with either, you should be able to follow along. I want to take a minute and just recover some items of nomenclature that we've covered in previous presentations that are just sort of related to how pScheduler works internally. One is that we have this notion of a test, which is a measurement that you're going to conduct in a very abstract form. We have a task, which is a job that you want pScheduler to do for you, which actually has a test embedded in it. And we have a notion of a run, which is one execution of a test, or of the test or a task. So tasks can have multiple runs. I'll talk about that in just a minute. Additionally, we have the notion of participants, which are quite simply, each participant is one of the pScheduler systems that's involved in carrying out a test. Most of the tests are sort of single-ended things like trace or round trip time or latency are all done on a single-ended basis. There are multiple participant tests, such as throughput, which involves having two pScheduler nodes cooperate in order to get the test carried out. Additionally, we can actually support tests with up to n participants. No one's invented a 3-participant test yet, but I'm sure somebody will come up with something in the future. We also have this notion of the lead participant, which is just one of the participants that takes on some special administrative responsibilities in getting the task done. It takes care of coordinating scheduling with other pScheduler nodes and takes care of collecting and assembling the results and producing the final result that gets fed back when everything is finished. Tasks have a life cycle that begins when a user, either a human or a system, but I guess since it's all software, it's all sort of systems anyway, but the user submits a task to the lead participant's API, and that task includes the test, some scheduling parameters, and other information. We'll talk a little bit about those shortly. After the task has been accepted by the system, pScheduler will schedule and create runs for the task. If it's just a one-shot task, it'll do just one. If it's a repeating task, it will schedule as many as necessary and keep scheduling them until the parameters that govern that say that it can stop. Each run in time is executed, and as each run finishes and the results are produced, the user collects the results, and that's sort of the whole life cycle from task to result. Documentation. I had actually anticipated releasing the documentation for this when we released 4.1 next spring. but there was some early interest, and I thought no time like the present, so we doing this a little bit early. There is a draft of the reference material that's shown at the bottom. I don't anticipate that there will be any changes in the API, so everything that I show you here should be consistent with what ends up in the documentation. The API has actually been relatively stable almost since its inception sometime last year. So let's dive in a little bit and talk about some of the REST endpoints that make up the API. At the root of everything is a URL that begins with HTTPS, a host name, and optionally a port. We do have the ability to run pScheduler on different ports. And then finally, of course, after that, pScheduler. We do this so that we can share the web server on the host with other applications that use it as well. The protocol for right now is always HTTPS. Things are hardwired right now that anything that is not encrypted will be rejected. You'll see why that is in a few minutes. So, for example, at the root, we can use the curl utility, and we can say curl-sk, S being for silent, and K being for not checking the certificates for the server. So we can pick out. We just picked out a fictitious host here, and we go pick out the root, which is just pScheduler. And when you get that back, you get back a string that's sort of pScheduler's version of hello world. You'll notice that this string has quotes around it. There's a reason for that, and that is that just about everything that comes out of this system is JSON. So pretty much anything that you fetch, as long as the result is a success, you will be able to treat whatever you get back as JSON and parse it appropriately. For brevity, I'm going to show some examples that will be just relative to the root, mostly so we don't have to clutter up the slides with a whole bunch of extra verbiage. So let's dive in and we'll take a look at some of the interesting endpoints up at the top. We've just looked at one. There are a few others that are not listed here, but you can do things like you can ask for the API version just by fetching API. Excuse me. You can ask the system for its clock state. We use that for diagnostics. You can ask the system what it thinks its host name is, and you can ask it how far in advance it will be scheduling runs. Right now, that's a hardwired value of 24 hours. That probably will change in 4.1. We have some software we have to put in to make it work with differing horizons. And some of the other things, there's also another subtree that I haven't shown here that has a whole bunch of statistical information that just kind of shows system state and how many things are backed up in various queues and that sort of thing. All that will be in the documentation. So down at the bottom here, we'll call curl again, and we'll just ask our fictitious machine what its host name is, and you can see here it just says perfSONAR2.dmz.example.com. We have a bunch of common parameters that you'll find on queries. The first and probably the most important one is the API version selector, which is just API equals and then an integer. It is required if you're using anything that is documented as being API version later than version 1. If you don't provide it, 1 will be assumed. Additionally, for any endpoint that returns JSON and any endpoint verb combination that returns JSON, you can also add the pretty parameter, and that will, excuse me, that will format the output for readability by humans. The default, of course, is not to do that. You get much more compact output from it. Finally, there are a bunch of endpoints that return arrays of URLs. Those are all gets. And those can have the expanded parameter attached to it. And what that will do is instead of returning a list of just strings that have URLs in them, you'll actually get a list of blobs of JSON that would be the equivalent of having fetched those URLs. So that way, if you want to do something like take a look at all the plugins of a certain type that are installed in the system, and you don't want to have to do, if there's 20 of them, you don't have to do 20 fetches. You can just expand it and get all the results at once. Additionally, we use dates, times, and durations in this system. Date and timestamps are done according to the ISO 8601 standard. I'm sure a lot of you have probably seen this format before. It's year, month, day, the letter T, hours, minutes, seconds, and an optional offset from UTC. The other piece of ISO 8601 that we use is its duration format, which is kind of unfamiliar to a lot of people. And the format for that is the letter P for period. and then optionally a number of weeks, a number of days, the letter T if you're going to be specifying anything of finer resolution than a day, and then optionally number of hours, number of minutes, number of seconds. So you can see in the example here, PT12S is a period time of 12 seconds. The second example, 1 hour, 3 minutes, 2 seconds. Excuse me. And then the third example, we have something that's got just things that are greater than a day. So we have 1 week and 2 days. And finally, we've got something that combines both of them. We have 3 days, and then the T for time, and then 4 hours, 19 seconds. One thing that is in ISO 8601 that we do not support are inexact units. You can specify months and years in this format, but we cannot support that because if you say a month, we don't know, unless we know which month it is, we actually don't know how long it actually lasts. If you find yourself wanting to run a test for months or years, please call me and I will be more than happy to discourage you from doing that. If you need reference material on this, Wikipedia has a really great page on ISO 8601, and it's a good reference. Has all sorts of interesting little bits about and examples about how to use this. And please, as well, if you're on the if you're on the BlueJeans client, if you have a question or something like that, please paste it into chat, and I'll try to get it answered for you. Additionally, I will be taking breaks between the major sections just to see if anyone has questions as well. So we do a few non-standard things, actually just a couple in our JSON. One of which is that we support comments, and the JScheduler, the pScheduler JSON parser is configured to ignore any pair where the key begins with a pound sign. So in the example here in the middle of the slide, you can see that there's a pound sign. This is a comment, and that will be completely ignored because the key in that pair begins with a pound sign. Same thing with the second one. It's a pound sign with some additional things, and you can also use that to comment things out. The third thing is not a comment because the pound sign is not the first value in the key, so that will get passed through just like anything else. I don't recommend using this for anything other than documentation. We use this quite a bit in some of the files that ship with the system, just as sort of a way to let people know what the JSON that's there does. But it's not, we support it, we'll ingest it, and we'll ignore it. But the pScheduler, any JSON that it produces will not use this at all, so you don't have to worry about feeding it to something else and picking things out that are or are not comments. So that shouldn't be an issue there. Another thing that we do is we have a security mechanism for content that gets put into pScheduler. There are a few places, mostly in task parameters and archiver parameters, where a key in a key value pair will begin with an underscore. And what that does, that tells the system that this is something that the system needs to use, such as a password or an authentication key, something along those lines, that you don't want the general public to be able to see when it's pulled out of the system. So, for example, on the left side, you have a thing that goes in, you have underscore secret, mumble, and on the right side, what you would get if you fetched the same endpoint that you had posted to, you just get the same thing with a null. Keys start with underscore in both directions. It's just part of their names. It's just sort of a signal for that says, hey, we're not going to pull this back out when it comes through. And the places where that occurs are in the documentation for the various things that use them. Additionally, we do use redirection in a few parts of the API. I think maybe there's 2 places that use it. We do that using the 303 status code that point at the correct content. Clients will need to handle those and not treat them as failures. Usually, you get used to treating a 200 status or a 201 as success and anything else as failure. So you will need to watch for those and handle them. If you're using the request module for Python, you can do this automatically, but the module has to be explicitly told to do so. In fact, if you take a look at the sample code that we're going to dissect a little later, you'll find that we do tell it explicitly. So if you need an example, you'll find it in there. Okay, I'm going to take a quick pause here. Does anyone have any questions so far? Okay, hearing none, let's move on. So now we're going to get into the meat of establishing a task and making pScheduler do something for you. First, we're going to take a look at the test without anything technical. We're just going to lay out what we're doing. And in this case, our example is going to be that we're going to measure throughput, and we're going to give that test 4 different parameters. We're going to say that the other end of the throughput test is ps.foo.org, which is some fictitious perfSONAR node someplace that's running pScheduler. We're going to limit the bandwidth of the test to 5 megabits per second. We're going to run the test for 20 seconds, and we're going to omit the first 5 because it's going to be TCP by default, and we want to give it some time to ramp up. Additionally, we're going to add a couple of scheduling parameters. We're going to say that we're going to repeat this once per hour, and we're going to do it up to 10 times. So all of this goes into a JSON structure that has all the information that's necessary for the task. You'll see here that some of the items are in black and some are grayed out. The ones that are in black are the ones that are required. The ones that are grayed out are optional. I am going to talk about all of them. I'll just cover some of them in more detail than others. Right up at the very top, we have a schema version, which in this case is number 1, and this is the specification version of, or it's the version of the specification. Right now, most of these things are at 1, so it is actually in some ways optional because we treat anything without one of these as being version 1. But in the future, you may have to change this to 2 or something else depending on what you're feeding the system. The second item is a test specification, and we'll talk a little bit about how to make one of those in a future slide here. And the third item that's required is scheduling information. Right now, it is required. It was kind of a slip in implementation. It is required that you have this, but it can be empty at some point, probably in the next release. We'll tweak that so it doesn't complain if you don't provide it. The items that are grayed out are, as I said, optional. The first one is tools, and you can provide a list of tools that you would prefer the system use. You can provide just one. So if you're doing throughput, you want iperf2 only, you can put iperf2 in that list. If you want to do iperf3 or iperf2 or nothing, you can say you can put iperf3 and iperf2 in that list, and the first of those that's available with all the participants is what will get used. Archives is a list of archive specifications. The details of these will probably actually be the subject of a different talk because it's a little involved and kind of would knock this thing off track. These are also things that you can generate. You can generate from the Commandline Interface. We'll talk about that in a second. Reference is another thing we provide, and that is just a blob of JSON data. It can be anything you like. It's really just for reference, and I'll show you how to use that later. But you will be able to take things out of the reference field and query on them, and go find things that you're after based on that. The final item is something that is kind of lying dormant in the current version of pScheduler and will be turned on in 4.0.2, which will be released probably in November. And that is what we call the task write password, or the key. And what that does is that prevents the system from making any alterations to a task, be it cancellation, scheduling new runs, or anything else like that, if not presented with the key. So it is just sort of a password. And things like this are the reason that we encrypt all the traffic. Aside from it's just generally a good idea to do so. Next, we're going to talk about how to make the JSON with the Commandline interface, and this is actually a really good stepping stone to doing it yourself. Because the Commandline interface and the API mirror one another, anything that you can do with one can be done with the other. And that makes the Commandline interface a really handy tool for putting these things together when you're just starting out, if you don't quite know what to do with it. The CLI has the task command has an option called export, which instead of submitting the task to the server to be scheduled, it will just generate the JSON and spit it out on the standard output and exit. Additionally, and this has been covered in a couple of other places, context-sensitive help is available. All you have to do on the CLI, you can say pScheduler task _help, and you'll get help that's appropriate for the task context. If you say pScheduler task a test type, e.g. throughput, and then help, you'll get help for what the switches are for throughput. And finally, you can also ask pScheduler what plugins are of a specific type are installed on the system. In this case, the one that most people will probably be interested in is tests. So you say pScheduler plugins tests, and you'll get a quick summary of what the plugins are, what they do, version numbers, and that sort of thing. So to actually make something happen with this, you'll put this command on the CLI, and I've sort of color coded the parts here. So you say pScheduler task, and you use the export switch to tell it that you just want JSON to come out of it. And in the blue here, you'll see that we have a couple of task-specific parameters. So we have the repeat interval, which is PT1H, or 1 hour, and we have max runs, which is 10. So we're gonna run this at 1 hour intervals up to 10 times, as we described before. We have the test type, which is throughput, and then finally at the bottom, the last 4 items in green are the test parameters, and those are specific to the throughput test. So you have a destination, ps.foo.org. You have bandwidth, which is 5M for 5 megabits per second. You can also do, you can do any of the standard multipliers. You can do K, M, G, and you can also, if you stick an I on the end, it'll do binary as opposed to decimal multipliers. You have the duration, PT20S, which is 20 seconds, and we have emit, which is another duration of 5 seconds. So once you've run this, and I hope this is large enough for everyone to see, but what you'll get out of this is a block of JSON that pretty much has the things that you put in on the command line nestled into the right places in the structure. The JSON keys all match the command line switches and vice versa, which makes it very easy to go from one to the other. Makes it a fairly easy transition. If you know one, you can pretty much get the other one together. So this is what comes out of it. Again, fairly straightforward and matches the structure that we talked about a couple of minutes ago. So here's where the rubber starts to meet the road. On the left, you have the JSON that we generated in the last step. And in order to get that into the server, you post it to /pscheduler/tasks. If everything went well, you'll get a 200 back that says it was successful. And you will also get a string containing a URL, which is sort of the unique identifier for that URL. It will be globally unique and includes things like the host name. I just put PS host in there just to keep it short, but that's pretty much the host name that you asked for when you went to do the post. And down at the end, you'll get a big string of numbers, digits, and hyphens, which is just a UUID that the system uses internally to represent the task uniquely. Pretty much anytime you're going to do something with the system, you're going to use the entire URL, not just the ID. These do get a little long, and sometime in the future we may start having the system return shortcuts. So if you're doing something with the Commandline interface, you don't have to cut and paste so much if you want to paste it into something else. Not everything goes successfully, of course. If you take a look on the left side, you can see that the duration of the task has been changed to 15 days, which any sanely configured system, of course, is not going to accept. And what you'll get back from that, instead of the usual 200 that you expect, is you'll get a 403 that says it's forbidden. You'll get an error message with this as well. Error messages are the big exception to our everything is JSON rule. And what you'll get back here is just plain text that's easy to peel out and display. You'll find that the command line interface uses this stuff verbatim. If something fails like this, it'll take what it got back and spit it right back out to the screen. So, assuming that everything did go well, once you've gotten the URL back, you can fetch it, and you'll get back pretty much the same thing that went in. So in this case, I just have an abbreviated version of what we got back. So we're going to get pScheduler tasks and whatever the task ID was, and what you'll get back from that is a 200 with everything that you put in, and the addition of a tool field, which indicates what tool was selected to run the task. This is we do this largely so that you can take something, pull it out of one system, drop it into another system, maybe alter a couple of things in the specification on the way, and have it behave exactly the same way. Okay, so we're kind of between sections here. If anyone has any questions, I'll wait for a minute. Okay, well, hearing none, we'll press on. And now we get to the point where we go to retrieve runs and results and things like that. We actually get to do something with the task that we just put in. Now, what I showed you before for getting the task is of limited use because you put it in, you kind of know what went in, so pulling it out doesn't make a whole lot of sense. There is, however, a parameter that you can add when you fetch a task called detail. And when you add that to the query string, you will get back an additional block of JSON called detail that has some additional information that's generated by the system for use of outside programs. So the command line interface uses this. Anything you write will use this. Mesh config uses it, that sort of thing. What you will find inside of the details are a whole bunch of links to other endpoints and some other things. And we'll talk about the links first. Most things that we return have an href field in them that just says this is what you fetched. This is, here's kind of who I am. When you go to fetch a task, you'll get 3 additional things back. The first one is called runs href, and that's a link to where you get the list of runs. The second thing is called first run href, which is where you go to get the first scheduled run. The third one is called next run href, which has a little bit of a kink to it. This gets the scheduled run that's going to happen, the next scheduled run that's going to happen after now. So until the first run happens, the first run href and the next run href will return the same thing. If you take a look at our 10-hour example that our 1 hour with 10 repetitions example that we showed beforehand, if you come back 5 hours later, first run href is always still going to be the same. Next run href will be the 6th one because it's been 5 hours and 5 of those have run already. I would advise you, please use these URLs. Don't build them manually. If I find out you are, I'm gonna change them in a future release just to be annoying. But really, this is sort of the restful way to do it. The interface passes you back pointers to where you need to go, and all you have to do is just pull them out and follow them. There are some additional things in the details that come back. Things like added shows you when the post was added. You'll get CLI, which is a list of the command line arguments that would be equivalent to what you submitted. You get duration, how long each run is going to occupy on the schedule, some information about the participants, some additional scheduling information like how much slip is allowed. There's a handful of other things in here. I didn't want to clutter the slide up too much. But by all means, when you start to play with this, feel free to take a look and see what's in there because there are a few useful things. So if you go to get the list of runs from a brand new task, and what you see here would be the equivalent of what you get back in the runs href, if you immediately go fetch that, you're going to get a 200 back, which says success, and you're going to get a whole lot of nothing for your troubles. The reason for this is that it takes a few seconds between the time the task is submitted and the time the first run gets scheduled. And this has to do with the communication that has to take place within pScheduler itself and between the lead participant and any other participants that are involved in finding a time to run it and getting it scheduled and coordinated and all that. As an aside here, I do want to point out that when it comes time to get runs and results and so forth, you don't actually have to continuously poll the system. One of the things that we have in pScheduler that gets used, if you're using mesh config, this is actually getting used quite a bit. But we have an archiving mechanism, which most of you are probably using just to archive to Esmond. But that mechanism also is extensible via plugins, and we actually ship a whole bunch of additional plugins as well. So when a result comes available, you can have the system posted to a URL using the HTTP archiver. You can have it send it to RabbitMQ if you have a RabbitMQ system. You can have it send it to syslog, the Bitbucket if you want. And coming in a future release, you'll also be able to format results into SNMP traps. This is something that was designed at University of Michigan for use with their single pane of glass system. and I expect that they're going to be using that quite a bit. How to use archivers is going to be a topic of a future presentation. I have probably 2 or 3 ideas for 2 or 3 more, and this will be one of them. We can go into the details of how to do that. But just kind of keep in mind that that's available when you're designing your systems, because it does prevent you having to hammer the system when you expect things to be ready. You can just simply have the system send it to you directly and not have to worry about it. So getting back to where we were before, which is in this case we're going to use the first run href, which is what's shown here in black, and that will wait for the first run to be scheduled by default. The default amount of time that it will wait is 30 seconds. You can add the wait parameter to the query string if you want and put a smaller number in there. The system will limit it to 30, so you don't camp on it for a week and a half or something like that. If everything went well, you'll get a 200 back, and you'll get back what's in the run as a blob of JSON. And if for some reason a first run was never scheduled, you'll get back a 404 that says just there is no such thing because it never existed. Inside the run, once again, you get a few links to other things. So you get the usual self-referential href. You get a link to the task to which the run belongs, and you also get a link that shows you where to get the result once it's available. Again, there are some additional items in here that may or may not be of interest depending on your application. You can get things like when the run was posted, a couple of items that show the current state of the run, both in sort of our all lowercase enumerated format and in a display format that's a little more better suited for humans. Get duration, and the last two are sort of the more important ones: the start time, which is when the run is scheduled to start, and the end time, which is when the run is scheduled to end. There's also some participant information. We sort of treat that as internal data. It's actually nothing that you can't get by fetching the task. It gets passed along for a variety of reasons that just make operations of the system internally a little bit easier. So other than the things that I show you here, I would treat anything else as internal data and not depend on it. So finally, once a result has been produced, you can go fetch a formatted result for the run that just happened. And the way you do that is you get pScheduler tasks, task ID, runs, run ID, and result. And this is what will be in the result href when you pull the run back. Additionally, you can see down here in the gray that I've also added a couple of additional parameters. One is that I want the format to be text plain. We'll talk about that in a second. Excuse me. And also, I also said wait, which says wait for the result. So what you'll get back again here, if everything went well, is a 200, and you'll get, in this case, plain text formatted results. And this is exactly the same thing that the CLI fetches, so it should look identical. There are 3 available formats for results. The first and the default is application/JSON. These are all just MIME types. And this is what you get back when you do this is the result in JSON format. This is a test-specific thing. It varies with each result. And this is sort of a narrowed down version of what you get when you go fetch the entire run. What you get here is actually just sort of a subfield of fetching the entire run. Additionally, you can get text/plain, which is, again, as I said, the same thing that's used by the Commandline interface. The third type that we have available that is kind of not fully grown yet is text/HTML. That's something we intend so that we can have the results be plastered into GUIs and that sort of thing. It is very bare bones output. It's usually just a table. You can slap a div around it and style it up however you like. As I said, this has not been. It's been mostly tested. There are a couple of plugins that currently do not properly format HTML, so it could just be a hairy point. We intend to have this squared away by 4.1 in the spring, so that'll become available by then. So just to sort of recap a little bit of this without all the URLs in the middle, this is the recommended way to fetch a result if you're going to wait for one. The first thing to do, of course, is to fetch the run so that you can get all the information about it. The second thing you'll want to do is take a look in what you got and look at the end time. Wait till the end time has passed. It doesn't hurt to wait maybe an extra second or two for the result to be collected and produced. It's not an instantaneous thing. It sometimes takes a second or so. And then finally, fetch the result href, which is what you got when you fetch the run with the wait parameter. And that will just wait for the result to be finished and return it when it is. HTTP server ports are limited, but they're not, they're not like severely limited, but they're not infinite either. And by waiting at least until the end time has passed, you'll keep the time that you're camped out on one of those ports down to a minimum, and hopefully the server shouldn't run out. Any questions so far? I see something in chat. Okay, so the question I guess popped up when we were talking about archivers before. Yeah, back on slide 30. Yes, that is absolutely. Let's see. Let me run back to slide 30 here, just so I answer the question properly. Yes, this is absolutely related to the archiving parameter in the JSON. Additionally, there is an archiving parameter in on the command line interface, which actually just takes JSON as arguments. I think maybe the archivers thing will be the next little short subject on this. Maybe I'll do that in a few weeks because it actually won't take too long to document. Does that answer your question? Assume yes here. Okay, so having been through all that, next thing we're gonna do is we're gonna dissect a sample program that was written actually just for this and is now part of the pScheduler sources. A little bit of pre-launch information. This is just a standard Python 2.x program that uses the requests and date util modules. Both of those are easily available and should be just a yum install away if you're running Red Hat or an apt-get if you're running something that's derived from Debian. What I'm not going to show you here, there are 4 functions in the program, and you can see the long version of the source at the URL down at the bottom of the slide if you want the gory details. But there are 4 functions that get used: URL post, which just does an HTTP post of a URL and returns the results. URL get does pretty much the same thing, just with a get. JSON load is used internally by URL get that converts JSON text to Python data. And then finally, we have a function called fail that just prints an error message and exits the program. As I said, that is available in the pScheduler sources at the link below. If you want to grab a copy. These slides are available, by the way. I did send out an additional announcement yesterday that has the URL for the slides. If anybody needs that, I will dig it out and put it up someplace at the end of this talk. So the first part of the program is what I like to call the configurables, which are just some things that you can configure to whatever your tastes happen to be. And in this case, we define 2 constants. One is called task, and the other is called lead. We'll talk about those in a second. The task should look fairly familiar. It's a JSON task specification, like we've discussed previously. And you can see here it's got a schema. It has a test that has in it a type and a specification. In this case, instead of doing throughput, we're going to do round trip time, and the spec has round trip time specific parameters in it. So we have a dest, which is we're just going to ping www.perfSONAR.net, and we have a count set to 3. We'll do that 3 times, and we also have an empty schedule, which just says that we want to do just 1. Finally, the lead that we define is the lead participant. In this case, we're just going to do it on a local host, so you'd have to run this on a system that has pScheduler installed. Alternately, if you want to ask a different system to do it, you put in that system's host name, and that's what will be filled in. So the first step, and this is kind of a recap of what I showed you earlier, the first step is to post the task. And the way we do that is we come up with a URL for where we post the task. This is probably the only place I will ever ask you to format a URL by hand, because everything else, as I said earlier, is going to be returned to you by the system when you ask for information. So in this case, we're going to do HTTPS. We're going to paste in the leads host name where the %s is, and we're going to post this to pScheduler/tasks. So next we take, we call URL post, and we post the task URL, and we do a JSON dump of the task that just takes that Python data and converts it into ASCII JSON so that it can be passed through to the web server. And what we get back from that are a status code, and we get task URL, which is what comes back from the server. It's where it tells you, okay, this is the handle. This is how you refer to the task. You do want to write your programs for this defensively, and that's just kind of good practice to begin with. But it is a good idea, obviously, not to forge ahead if you haven't gotten anything that you wanted, everything that you were expecting to get. So in this case, for example, we catch exceptions, and we just call fail, and we say we can't post the test if we didn't get if it threw an exception to the process. Additionally, if we get a status back that's not 200, we fail as well, because really all we want here is a 200. I did mention earlier that we have to be able to handle redirects. That is actually something that's turned on in the URL post function, so that gets taken care of automatically, and the requests library will take care of fetching the next thing that the server directs it to. Finally, down at the bottom, we just spit out what the new task's URL is for reference. This program, if you run the full version of it, will kind of show you what it's doing and show you some of the interim parts as it runs. So the next thing that we can do is we can go fetch the task with its information. So we get back, we call URL get with the task URL, and we add this additional parameter called detail that we talked about earlier. Detail really actually only needs to be present. It doesn't need to have a value. Although if you put true or false or 1 or 0, or I think even yes or no, the system will take care of understanding that and interpreting it the right way. Again, what you get back when you call URL get is a status value and the task data, which is just JSON that's been converted into Python data structure. Now I pulled out all the defensive stuff here because you've seen it once, and I don't want to clutter the slides up by repeating it. Finally, after we're sure that we got something good back with a 200 and no exceptions, we check and make sure that the task data has in it, in the detail field, the first run href, which is something that we need. If it throws a key error because of that, because either detail or first run href was not present, then we fail because the server has returned incomplete information. So again, shouldn't happen. I haven't had the server fail like that yet, but there are other things to deal with, such as network interruptions and that sort of thing. And I'm sure probably eventually someone will turn up a bug in this that'll make it behave the wrong way. So the first run URL that we got in the last slide, you can go fetch. Oh, I did actually want to point something else out here in the previous slide down at the bottom. This is kind of a redundant step. Right now, in the current version of the API, you actually have to get this. You have to do this get separately. There is going to be something probably either in 402 or 4.1 that will allow you to modify your post so that you get back the full version of the task with the information in it, so that you don't have to do a second fetch. And that actually will just be by adding the expanded parameter. Anyway, so we do pretty much the same thing with the first run. And again, as I mentioned earlier, the default behavior when you ask the server for this is to wait for it to be created. So we do the usual things. We check for a 404, check for a 200. And additionally, we check for a few things in the information that we get back. We're looking for a start time, an end time, and a result href. Again, just to make sure that the things that we use later are present. And if we get to the bottom of that, then we haven't failed, so then everything's happy. Finally, we wait for the run to finish. And the way we do that is we use the date util to take the end time out of the run data. We figure out what time it is. We can complain if we get a value error because it's not there. There's a little spot. I didn't paste the code in here because it makes the slide a little bit cluttered, but we figure out how many seconds that we have to sleep until that time elapses, and finally we sleep that long. So by the time that sleep exits, the run of the task will have finished, but not necessarily the result may not have been produced yet. So the first thing we do is we fetch the machine readable result, because we're going to do a few things with whatever is in the with whatever's in that. So we do a URL get. We go back to our run data and we look for the result href that says, okay, where do we get the result? And we add a parameter here called wait merged, and we set that to true. There are several sort of intermediate versions of the result, and the one that is the final result is called merged. It's called the merged result, and it is sort of the final one. So we tell this, wait for the merged result to be produced, and don't return until it's been until it's there and it's ready to consume. Again, we check the status. If we didn't get a result, if we got something other than a 200, we complain about it. Otherwise, we take a look and make sure that the test ran properly. There is an item in every result called succeeded. That is a standard thing and it's required, that says whether or not the run succeeded. And that's just a JSON binary value. It'll come out true or false. And if it's false, of course, you can say it didn't run. And in this case, we just call fail and complain a little bit. Finally, we're getting into the home stretch here. Finally, we go fetch the human readable result. And this is pretty much the same as what we did last time in the last slide. The only difference is that instead of just getting the default, which is JSON, we're going to ask it. We're going to tell it to format it as text plain. Additionally, there's a parameter to the URL get function called JSON, which just says whether or not the result should be parsed as JSON. In this case, because we're getting plain text back, we want to turn that off so it doesn't try to put it through the JSON parser and have it throw up on it. So again, if the status of this is not 200, we complain about it. Otherwise, we spit the result text out, and that was just plain text. And what we get is the final product, and that looks a lot like this because we did a round trip time test. This is exactly what you would see if you did the same test in the command line. The CLI fetches the data exactly the same way, and you'll get exactly the same results. Same thing goes again if later on, once we get the HTML parts cleaned up, you'll be able to fetch HTML and do things with it as well. Okay, going to take another pause for questions. You can either post it in chat or if you have a question, feel free to unmute and ask. Okay, well, hearing none, we'll press on. This is kind of the last major section here. And this is just other interesting things you can do with the API. This is not all of it, but it is sort of some of the highlights. The full version, of course, will be in the full version of the API documentation once we get it out the door. If you have a task that is either if it's a one-shot or even if it's a repeating task, if you want to cancel it, you can use the delete verb to get rid of it. And what you would do is you just say delete and whatever the URL you were handed back when you first posted the thing. What that does is it cancels any runs that have a start time in the future. So that means if it's a one shot and it just hasn't run yet, that'll be canceled. If it's a repeating task and you're halfway through the repeats, then it'll just cancel the last half, and because the other ones have run, it'll be in the system already. And it also prevents scheduling of any future runs as well. Now, no data is actually deleted from the system here. All of it stays, and you can cancel this. You can cancel these as many times as you want if you feel like it. But really, only the first one has any effect. Finally, and this is, I think, one of the neater things you can do with this. You can filter when you go to get the if you get the tasks endpoint. If you just ask for it unadorned, you're going to get every task that's registered in the system, which can be quite a bit on a fairly busy system. So we give you the option of adding this JSON parameter to the query string, which has in it a URL encoded JSON pattern, and I'll talk about this in a second in detail. And what you get back from this, depending on whether or not you use the expanded item, is you'll either get back a list of URLs, or if you expand it, you'll get back JSON containing the actual tasks. The comparison that it makes is against the fully detailed task, so it's the equivalent of looking at what you get back if you ask for the details. So just to show you some samples of things you can query against here, this is how you would get all of the throughput tasks. And if you were to look in the fully detailed version of a task, what you'd see is you'd go, okay, well, I go down to the test item, and then I go down to the type item, and that's a string throughput. So what will happen if you give it this JSON pattern, it will find everything where it'll find every task where that exists exactly like that. Same deal with the second one. This goes down into the details, and it looks for enabled and true. Enabled, when you ask for the details, will always be in there. It'll either be true or false. Finally, this is where we use as an example where we use the reference information, which again is just an arbitrary piece of JSON that whoever submits the task can supply. So it might be, in this case, maybe somebody's submitting tasks that have a reference that have a batch number field in them, and you want to see batch number 3806. This will pick out all the tasks that match that. This is a more complex JSON filter. You can actually make these as complex as you want, and it's sort of a combination of some of the things that I showed you in the previous slide. We're looking for tests of type throughput. In the details, enabled has to be true, runs has to be 0. For example, if you're looking at things that haven't run yet, and here's our item where we pick things out of the batch number. Unfortunately, there isn't a whole lot we can do with this in terms of doing more, really sophisticated things like saying, runs is greater than 6 or anything else like that. This is actually something that we pass directly through to the underlying database that underpins all this, and it can do queries on these things fairly quickly. What's important here is that all this data must match exactly for it to appear in the query when you go to pull it out. You can also examine the schedule, which is sort of pScheduler's appointment calendar that it keeps internally. Shows you what's on the schedule for a particular range of time. If you just ask for the schedule without any additional parameters, you'll get the system's entire schedule from the dawn of time until the sun burns out. Usually what that interval looks like depends on how the system is configured. There is a configurable retention period. Actually, right now it's set at 2 days, and that'll become the actual configurability will happen in 4.1. We'll bring that knob out to the front. So if you ask for everything, what you're going to get back is 2 days worth of runs in the past and 24 hours worth of runs in the future. If you want to do some different, if you want to filter that more tightly or to a specific interval, you can provide a start and end parameters. You don't have to provide them both. If you don't provide a start, it will assume the beginning of time. If you don't provide an end, it will assume end of time. And those are both just ISO 8601 timestamps, as was described earlier. What you get back in these, what you get back if you query the schedule, is a whole bunch of data about the run. So you get things like the start time and the end time. You'll get couple of items. You've seen these before. The state of the current state of the run, both in our kind of all lowercase enumerable format and human readable. You'll get command line arguments, and you'll get any error messages that happen during the run, or null. You'll get null back if the run hasn't happened yet, or if there were no errors. Additionally, you get a couple of links. href is the link to the run itself. Result href is just where to go to get the result. Additionally, it also adds in enumerated versions of information from elsewhere in the system. So you will get the unexpanded version of the task. You'll get the full enumeration of the test that you're running, and you'll also get the full enumeration of the tool that ran it. Finally, I think this is almost all of it. You can also ask the system what plugins are installed on it. This is important because while most systems will probably run the standard set of plugins that we ship with pScheduler, there may be some where that either have custom plugins installed or may have had some of the standard plugins removed because the administrators don't want a system to be capable of doing a particular thing. For example, if you want to render pScheduler completely incapable of doing throughput tests, all you have to do is remove the associated plugins, and it will never know that throughput even exists. But the way you can ask for a list of a particular type of plugin, and this is what underpins that command line option I showed you, the command line interface trick I showed you before, you just get pScheduler / what, and then what is going to be either tests, tools, archivers, or contexts, depending on which plugin you want to, which list of plugins you want to get. This returns an array of URLs that are endpoints for each plugin. And as usual, because this is sort of a standard thing, you can also expand those with the expanded keyword. So this is actually pretty much all there is to it. There are a few things, as I mentioned, that I left out that are not really critical to getting pScheduler to do things for you. And you know, the API will probably expand a little bit as we add features to the system in the future. You know, if you guys have ideas or anything that you know, things that we're not doing for you that you think the API should do, by all means, please drop us a line. Our addresses are down there at the bottom. This is pretty much the end of the presentation, and since we have half an hour left, I'm going to open it up to Q&A. Questions? Anybody? I guess everybody might be muted here. Let me see if I can unmute everybody there. So, okay, yeah. If you have a question, just you know, feel free to chime in. I know it's a lot of material. Okay. Well, I guess hearing none, I think we'll wrap it up. As I said, please you know, please drop us a line if you have questions or anything else like that. The slides are available. Let me paste that into chat. Give me just a minute to dig that link out for you. I will paste it into the chat momentarily.
Hi, I think there are a couple of questions in the chat section.
Yep, there sure are. Okay, let's see. Can I live demo pulling up the results for the last 2 days? Sure. Let me stop sharing the presentation here and crack open a terminal. Pardon me. Do apologize for the cough. There's a lot of it today. Sure. Let me. Let's see. Let me go share my screen here. Okay, so I've just shared a terminal. If everyone can see that, hopefully the type's big enough. So what I'm going to do first, actually, is I'm going to run the command line interface command that does the equivalent. And what that is going to be pScheduler. Type here. Command for that is schedule. And what you can do with this is you can give it either a pair of deltas, or you can give it a start and an end. So what I'm going to do here, so just to show you some examples, you can say schedule minus PT1H will show you an hour in the past up till now. PT25M is right now through 25 minutes in the future. And finally, here's another one that's minus an hour to 30 minutes. This, however, down at the bottom is probably the one that's going to be closest to what you're going to want to look at when you use the API. So what I'm going to do here is I'm going to run, let's see, so we'll say, we're going to say pScheduler schedule. And I'm going to do this on a different host because the machine that I'm on right now is not particularly well loaded because it's just one of my VMs. I'm going to tell it to go look on a different host, and I'm going to tell it that I want to look at what's going on from, let's see, 2017. Today's the 19th, so 09, 19 time, and let's do from, let's do from 8 o'clock this morning to, and we'll do 8 o'clock to 9:30. I think that should probably give us a whole bunch of results here.
So this is a dumb
I'm going to pipe
question.
this through less.
So are you running the pScheduler command on the perfSONAR host itself?
No, actually. What the host switch does here, actually not sure why this is taking so long either, because it shouldn't. Oh, there it goes. No, what I did was, I'll show you this in a second. But what I did was, let's take a look at this while we have it on the screen here, and I'll go back to the Commandline interface. But what this does is this shows you the range of times for each run. It shows you the state of the run. It shows you what kind of test it was, what the command line options would have been, shows you what tool it was, and all this is all just derived from the JSON that you get back. And then finally, down at the bottom here, it gives you a URL that points at the run. So what I did here was I used this host option that says, instead of asking the local host, which is done by default, it asks that host for it.
So this is a third-party test, in a sense?
Yeah, pretty much everything. The way pScheduler was designed is there really actually isn't a notion of kind of second or third party anymore. There just sort of happens to be a happy coincidence that if you ask from the local host, the machine just sees it as being on the local host, and it doesn't differentiate from asking from the local host or somewhere else. So now what I'll do though is I'll take what we just did and I'll turn it into an actual call to the API. So we'll say HTTPS. We'll say perfSONAR dev0.internet2.edu. We'll say pScheduler. Make sure it's typed properly. And we'll say start equals. I'm going to see if I can get away without URL encoding this. I think I can. Let's see. Let's see what we get back from this. The machine we're querying is a VM, and it has kind of a load on it sometimes, so it sometimes takes a bit to assemble all this and bring it back. But what you see right here is what you would ask the API for. Oh gracious, we've got quite a lot back there. Let me run this again, and I'm going to make it a little shorter this time. We'll just do the 8:10. I'm going to add the pretty parameter to it, so it formats it so it's readable. There we go. We'll just scroll through some of this, and this is what you get back. You just get back a whole list of the information that I showed you in the slides there. That answer your question?
Yes.
And another question: where is that information stored? It comes with pScheduler itself, or do you need the archiver to be able to retrieve it, or is it the same database? Is separate?
Yeah. What's actually going on here? One of the things that pScheduler does that BWCTL did not, it has its own database internally, and will store things that happened previously for. Right now we have it set for 48 hours. So what that means is if you have a task that ran 2 hours ago, as long as you still have the URL for it, you can actually go back and refetch that result if you want it. Archiving is just sort of the process for pScheduler to get rid of something once it's run. So, for example, you're used to putting the stuff into Esmond or something else like that. And really, if you want something for long-term storage, you are going to want to archive it somewhere else.
Okay, but if you run it and then retrieve the results in the same day,
it will be there. Yes,
it'll be there. Okay, you don't need. So what's the minimum? Packages that we have to install to get this much then?
Actually, this is all a standard part of pScheduler.
Okay.
So if you install, for example, you install the test point bundle, all of this will be there. Any of the bundles that you can use to run tests with, this is all there. It's not. There's nothing additional for it. It's part of the core part. If you just want the server, there's a package called pScheduler server, but it doesn't have any of the plugins or anything, so it won't know how to run tests and things like that. I'm trying to remember. I think we distribute. I'll actually have to go look. I think we may distribute a bundle called pScheduler Full that just has pScheduler. If you want to drop me a line afterward, I can give you the specifics. They just escaped me at the moment.
Okay, thanks. Yeah, I was just trying to understand the relative the relative things there. So, but if we do use that third party that you don't like to call like that, then you would only need the pScheduler itself because you ask somebody else to about the results.
Yeah, there is a package. If you want the command line stuff, there is a package called pScheduler Core, which just has the command line bits. If you're going to do something where you're going to write a program and you're going to use the API through the program, you don't even need that.
Oh, right.
All you need is just whatever library you need to go post and fetch URLs in your business.
Very good.
Okay. Anyone else have a question?
So, do you have a quick example of RabbitMQ as an example of an archiver?
Sure. Give me 1 second to pull that up here. Let's see. I just happen to keep a bunch of those in my back pocket. So this is what the archive specification looks like. We actually have some time here, so I can actually talk about this a little bit. This is what the archive specification looks like for RabbitMQ. In this case, I was just doing sort of a little hello world example. But the way these work is you say archiver and you specify which archiver you want. And then you specify another blob called data that what goes in there depends on which archiver you're using. But in this case, we have a URL, and you'll notice the underscore at the beginning of the name there, which indicates that goes in but doesn't come out. The reason for that being that any authentication information that you put in goes in with the URL. But you get the routing key. Then we have this thing called retry policy, which is actually something that we built in, and this just says do 5 attempts at 5-second intervals, and then do 5 more at 30-second intervals, and then give up.
Right.
So we do have documentation on all these. I can fetch that out for you if you want. I'll paste it in the chat. There are a whole bunch of things. There are a whole bunch of topics like this on the pScheduler wiki. If you go to GitHub/perfSONAR/pScheduler and you click the wiki link, you'll find that there are pages that cover all this stuff. Additionally, a bunch of this has been folded into the kind of main perfSONAR documentation. I actually haven't looked at that in quite a while, so I can't tell you which pieces have and which haven't. But there's a big pile of examples and things on the wiki.
Right. So as I understand, so if you pass in the JSON as an argument with archive and point to this blob of this JSON blob to give it the RabbitMQ URL and a routing key and everything, the test results would be automatically sent to this RabbitMQ server. Then I just need to write a listener for that to actually archive it somewhere else.
Let me see if I have RabbitMQ running on here. I'll show it to you.
All right.
Let's see. 1 second here. Oh, actually, let me go do this. Let me go do this on a different machine that does, but I'm pretty sure it does have RabbitMQ running. So what I'm going to do here is I'm going to do pScheduler. I'm going to say task, and I'm going to say I'm going to do a really simple task called idle, which does absolutely nothing. And I'm going to say the duration is, let's just make it sit idle and do nothing for 2 seconds. I'll explain what all the punctuation means in a second. So what I'm going to do first here is I'm just going to show you how this works through syslog because it's easy. Let's see. Okay, so here's this actually makes use of a give me 1 second to edit this. I just want to make it as simple as possible for you. No, I'm going to take this out. So this is what the archive spec for syslog looks like. Looks pretty similar, except we say we use syslog and we have a different set of data. And this was just something left over from a demo at Global Summit. So what I'm going to do here is I'm going to tail the system log. And then I'm going to run the task here. So what I did was I said archive, and then I said an @, which means the rest of the argument is a file that you can pull it out of. And I'm just going to pull this out of my home directory and have it run it. So this will go for a minute, and if I play my cards right. Okay, so you can see right here down at the bottom, all it did was it took the it just took the raw JSON and dumped it into syslog. Similarly, if we want to do this, let's see. Let's see. I think I have a little script to take care of this. Yeah. Okay. I have a little program here that just listens on the hello queue for RabbitMQ. So let me put this piece back. Okay. So here's your RabbitMQ archiver. This is what we looked at a second ago, and we're just going to post it to localhost, and we're going to post it to the hello key. It works pretty much the same way. So instead of saying I'm just going to read it out of a different file, I'm going to read it out of the RabbitMQ file, and we'll let it run here. I will probably be doing a separate talk on archivers because there's several of them that are interesting. And there you go. So we just got that we received the raw JSON.
So this is the output of the test?
Yes. Yes.
Okay.
Yeah. In fact, you can see here. Let's see. So let's see. So we've got the schedule information. We've got the information about the tool that was used to run it. We have a list of the participants. In this case, which is dev7, which is my dev machine. We've got the result, and this is the actual result of the test. This part that I have highlighted right here. So you can see that it said the duration was 2 seconds, and it succeeded, and the schema version is 1. This is a ridiculously simple test that I built just for demonstrations and for working on the infrastructure. So there's not really a whole lot in it. And additionally, you can also see what the specification of the test was that ran. So you should get enough information out of that to do whatever you need with it. That answer your question?
Yes, thank you very much.
Cool. Anything else? Let's see. We have a question here. Oh, we got a bunch of new questions. Okay, we're kind of getting general topics here, but I have some time, so we'll do that. The first question is how does pScheduler handle security? We have a pretty extensive limit system built in. You can ask pScheduler to do pretty much anything you want. The limit system, and this is yet another subject of conversation for a talk. But the limit system will allow you to do fairly sophisticated things, like say, the people on this block of IP addresses can't do bandwidth tests that are UDP or any more than X megabits per second, that sort of thing. There is not right now a login mechanism. We didn't want to. There are actually a lot of things that we can do security-wise that we have not yet, in terms of things like authentication and that sort of thing. We will probably think about doing some of those in future releases. What we have now, limits-wise, is considerably more sophisticated than what VWCTL had. So it is a step up. So I don't know if there's anything else I can tell you on that front. The next question was: Is there a way to authorize only certain users to schedule or retrieve things? I'll hit the second part of that question first. Right now, it's pretty much if you have the URL or you can get it from the system, then you can retrieve things. One of the things that I thought about doing with the password mechanism, and I may change this later, is making things read only. And the first iteration of that is going to show up in version 4.0.2. And I may consider doing some additional things so that you can say this task is only readable by people that have the key that goes with it. There are a couple little hairy points that have to be worked out for that, and I'll have to kind of work through some of those. So the first part of your question about whether or not you can authorize certain users to schedule or retrieve things, right now that's done by IP address. As I mentioned a second ago, we're probably going to look at some other ways for people to identify themselves to the system, maybe by using federated logins or something else like that. It's just, this was not something. What we tried to do in 4.0 was to get us at least to feature parity with 3.5, because this was a big change. So there will be some additional features along those lines coming in the future as we have time to do them. Finally, the last question I have in here in chat is: how easy or difficult is it to add new tools to pScheduler? It's actually fairly easy. This was one of the things that drove us to write pScheduler in the first place, was the fact that there were a lot of people who had things that they wanted to measure that VWCTL was incapable of handling. And one of the first things, I started here 2 years ago on this project, and one of my first jobs was actually to go through and evaluate whether or not we wanted to continue developing VWCTL or do something new. And you can kind of see what happened. The answer was to do something new. But pScheduler is designed to be very extensible. You can add, we have 4 types of plugins. I'll talk to you about 3 of them right now, because the 4th one is really sort of an arcane thing. The first type of plugin that we have is called a test, which is just a very abstract representation of what the measurement is. The reason we keep the tests abstracted is that we can have multiple tools that carry them out. So, for example, in the trace family, we have this test called trace that is basically, it's a trace route, but we have a bunch of different tools that can carry it out. We have traditional trace route, we have trace path, we have Paris trace route. Someone asked, for example, could we add Dublin trace route to that list? The answer to that question is yes. It would be very easy. It would just be a matter of writing a plugin and installing installing it on the system, or making it part of the standard distribution. The second type of plugins that we have are called tools, which are actually the things that carry out the tests. So, for example, if you say I want to do a throughput test, by default that's usually going to be handled by iperf3, but we also have new TCP and iperf2 as well. If somebody came up with iperf4 or some other tool that can do the same test, all we would have to do to integrate that is write a plugin that figures out, okay, I've been given this test, what do I have to do with the program to make it carry that out? So I hope that answers that question. Finally, we've got at the bottom a more general question. Is there a way to generate graphical output on the CLI with pScheduler, e.g. throughput versus time, or can that only be done through the web interface? There is actually a command called plot schedule. In fact, let's see. Either plot schedule or schedule plot schedule. And this is identical to the schedule command that I showed you. The only difference is you can see that the command line arguments are the same if you're looking at the screen here. But what that will do is that will produce a graph as a PNG out to standard output that will show you what's on the. It just kind of shows you what parts of the schedule are occupied. As far as I see. It looks like you're actually asking for the results, throughput versus time. Right now, that is all done. Right now, it's all done through the web interface. One of the things that I'm kind of agitating for, and we can do this now because we have kind of better archiving. But theoretically, I guess if you were to pull out, say, all of the throughput tests, you could actually pull the results one at a time and do that information. You can do that right through the API if you wanted to. Typically, what we're doing right now is a carryover from what we had in perfSONAR 3.x, where excuse me, where we had all the results were archived to Esmond, and all the graphical things that you see in the web interface actually get their data from Esmond rather than directly from pScheduler itself. As far as what we're going to do in the future with that, I'm not real sure. Again, you can sort these things out through the API as long as they're still in the system, which right now, as I said, is 48 hours. My recommendation, though, if you're going to do any kind of real analysis of your data or anything else like that, it's probably better to send it off somewhere else, to a time series database or something else like that. One of the things I don't want to do is get pScheduler itself into too many, into too many different businesses, because there are certainly plenty of other tools out there that can handle a lot of this stuff very well, and it doesn't make a whole lot of sense to reinvent the wheel. So, Mark, I hope that answers your question. Cool. Okay. We've got about 6 minutes left. If anyone else has any questions, please either put it in the chat or chime in.
Well, thank you very much. That was very useful.
Good. Somebody, whoever it was that first wrote me about this, told me they had sort of an unusual application for the API, and I wrote him back and I said, no, this is exactly the kind of thing I want people to do. So the API is there so that pScheduler can become a building block for other systems, and I really hope to see a lot of that in the future.
Yeah, I'm not sure it was the first one. I may have been the second one.
Yeah, but yeah, definitely though, this is exactly the kind of thing I had in mind when I built this. So by all means, please have at it, and drop me a line and let me know how it goes for you.
All right. Yes. Thank you.
Okay. Well, I guess if there's not any other questions, I think we'll wrap it up. Thanks everybody for coming and listening to me drone on for an hour and a half. Sounds like it was useful. And once again, if you have questions or anything else like that, please either drop the developers a note on the perfSONAR developers list, or if you have questions about how the API works or anything else like that, send a note to the users list, and one of us will get back to you. Okay, well, thanks very much. I'm going to wrap up. Enjoyed it.